In science, when we do experiments, we have to take measurements of things. And there's two concepts that are really important with our measurements: accuracy and precision. I'm sure you've heard of these terms before, and you might have even used them interchangeably, but they're not actually the same thing. Accuracy is how close to the actual value, the real value, your measurement is. So if you've got a mass that we know is 10 kilograms, and we put it on the, and you put it on the scales, and the scales read 7 kilograms. Well, that's not very accurate because it's not anywhere near the actual known value. So accuracy is how close your measurement is to the real value. So we obviously need to be focused in science in being as accurate as possible. So that means we use the right equipment for the measurement. That means that we ensure that it's calibrated. Like, for example, if we go back to thinking about measuring mass on a mass balance or a scale, we need to make sure that we tare it, or we zero it before we start. If we don't do that, it's not going to be accurate because the actual measurement is not going to be close to the real value. Now, the next thing is about precision. Precision is how close two or more measurements are to each other. So this time we're comparing measurements to each other. So if you use the scales and measure the mass 3 times, you want to see that the value that you measure each time is going to be very, very similar. So I want to talk you through 3 examples using targets in archery for precision and accuracy. So the first one, so we're doing archery here and we do 7 trials. Now, these 7 are not in the bullseye. They're not where we were trying to aim for. So they're not very accurate. So this example here has got low accuracy. However, all of our arrows are very, very close together. So it has high precision. So that's one scenario. Over here, another scenario we have is, actually I might do this one first, but this one's a little bit harder to understand. Let's say we've got, again, 7 arrows. Now, I want you to see that they're all kind of over the place. If we were to average those, add them all up and work out an average, can you see that the actual average is going to be right in the center? So it's the funny thing about doing averages sometimes is that, you know, each of our measurements doesn't look very precise. It's not precise, is it? So it's got low precision. But if we took an average, we'd actually be quite accurate. So this is actually a reason, really important reason why in science we do a number of trials to get repetition and consistency. And that's part of the scientific method. And so we actually can say here that we have got high accuracy. Final. This is really what we want in science, of course, isn't it? Imagine being that good at archery. What does it look like? Well, they're right in the center and they're all together. So we have got high precision and high accuracy. So they're the things that we're focusing on in science, is trying to be accurate and precise. We try and ensure we're accurate by using the right tool to measure and making sure it's calibrated, making sure we're reading the right way, making sure that we're very, very careful with our recording and we write it down straight away. Making sure that we're precise, so we do a number of measurements using the same process, the same technique and the same protocol, but importantly we do more than one trial to ensure that we can take some averages. There you have it, accuracy and precision.